We keep going. We're at number 4, which says, write the function in the form y equal to f of u and u equal to g of x. This is just what we do when we do chain rule, right? Then find dy dx. So there's nothing special about it. This is what we do when we do chain rule. Because if you go to like page 12 in your functions, you see the statement that says that if y is equal to f of u and u is equal to g of x, okay, it says then you should know that dy dx is equal to dy du. The then is usually put on this line. You say then you say dy dx, the derivative which they want, will be just equal to dy du times du dx. So this is the statement, okay, that if y is this and u is this, then dy dx is dy du times du dx. This just means put y in terms of u and u in terms of x, which is very simple. We know that u will be the inside function. That's how you do this. This is very simple. Let's go to the questions and let's see here. We have here y being equal to 2x plus 1 to the power of 5, okay? So we want to be able to do this and then find dy dx like this, because that is, if you do this, then this will be your dy dx, basically. So they want you to express y in terms of u and u in terms of x. In other words, to then find dy dx, they want you to use the chain rule. How do I do that? So here you have your number a on 4a. It says y is 2x plus 1 to the power 5. This is so simple. We know that here there is a function which is this inside another function. So this function inside is inside this function of x to the power 5. We know that if we have y being equal to x to the power of 5, this is a function, and this will be a polynomial function. But if I now come to say y is equal to, instead of just an x, if I put something else which is not an x, 2x plus 1, then that whole thing I raise it to the power 5. This now becomes a function inside a function, because 2x plus 1 is a function. X to the power 5 is a function. Now if I say 2x plus 1 to the power of 5, I have a function 2x plus 1 which is inside a function of raising x to the power 5. So now this becomes a composite function. And all you do every time you have a lot of stuff inside here, then them being raised to a power, what you just do is you let u be the inside function. That's what they mean by let u equal to g of x. So you're going to say here, let u be equal to 2x plus 1. This now means that y will be now equal to u to the power of 5. Now you have the thing. Y is now a function of u, because 2x plus 1 is u. Y is a function of u and u is a function of x. U is in terms of x. It's a 2x plus 1. Y is in terms of u. So that's what they just meant. Y is now u to the power 5 instead of 2x plus 1 to the power 5. So now you can find your du dx. What is your du dx? You find the derivative of u. Derivative of 2x is 2x. Derivative of 1 is 0. So it's not. Derivative of 2x is 2. Derivative of 1 is 0. So you leave it. Then now you can say, what is dy du, the derivative of y with respect to u? Because here it is in terms of u. What is it? Well, here you use the power rule. What do? Drop down the power 5, reduce it by 1. U to the power of 4. Then now I can come and say, dy dx, you already have. You now know how to get your dy dx. So it's just dy du times du dx. Okay. So now we can just say it is dy du. I have it here. It's 5u to the power 4 times du dx is 2, which becomes 5 times 2 is 10. 10u to the power 4. Now, what is my u? I have it here, 2x plus 1. So I can say it is just 10 of 2x plus 1 to the power of 4. And this is going to be your final solution. And you have done. You have expressed u as g of x, y as f of u. In other words, y in terms of u, u in terms of x. And you found the derivative. You know that once you do that, derivative is this according to the slides. You can go to like page 12 out of 27 of like your lecture 6. You see that the statement which I just put for you here. This is the one which they wanted you to be able to use and apply. This is going to be your dy dx, and you'll be done. That's what they wanted, and that's it. Goodbye for now. See you in the next one.